In this video, I want to talk about factoring trinomials. Before we talk about factoring trinomials though, I want to apply this to something that we should already know. If you're watching this video, you should already have an idea of how to multiply two binomials like what you see here in front of you, meaning FOIL is probably the way you were taught to do it, or double distributive property. The idea here would be you take x times x to give you x squared, x times negative 5 to give us negative 5x, 7 times x to give us 7x, and 7 times negative 5 to give us negative 35. And then you could combine your like terms to get x squared plus 2x minus 35. This is a trinomial, right? This is an expression that has three terms, hence the tri in trinomial. So what we're going to be doing today is basically the reverse of this process. We are going to start with a trinomial, like what I've highlighted here in yellow, and we are going to try to factor that into two binomials, like this x plus 7 and x minus 5. Now what I want you to notice about this is notice that when we look at the factors that we started with, the two binomials here, 7 minus 5, this positive 7 minus 5, gives us the 2 for our 2x, and 7 times negative 5 gives us the negative 35 here for our last term. Also, x times x gave us the x squared. Now if all of that is something that you can see, that pretty much covers what we're going to be doing for factoring. Meaning, for example, if I gave you x squared plus 5x plus 6, all you really have to do is find two factors, or find two numbers that would multiply to 6 and then add to 5. And if you can find those two numbers, you can use them to make your factors and you'd have your answer. Now while that sounds simple, I recognize that that can be a lot to keep all in your head, especially if we're dealing with bigger numbers than just 5 and 6. And so to that end, over all the years that algebra has been taught, there has been multiple different quote-unquote methods that teachers have come up with that are basically just a bunch of different organizers. They're just different ways to organize all that information I just said so you can find your numbers. The one that I prefer to use is called the X method. This is the X method. So the idea would be, up here at the top, we've got a generic quadratic function. So A, B, and C are what we are interested in. A, B, and C are all representing numbers. A being the number or coefficient in front of x squared. B being the number or coefficient in front of x. And C being the number that's just a constant. It has no variables with it. What we want to do is we're going to set up this X method, which is a way of organizing the information I just said before. We're going to take A times C, meaning your first and last number, and we're going to put that in the top of our X. Then we're going to take our B value and put it in the bottom slot of the X. What we're interested in is finding the two side numbers, we'll say, and those are going to be the numbers that we use to build our factors. Those two numbers need to be numbers that multiply to A times C, multiply to the number in the top of your X, and add to B, add to the number in the bottom of your X. You should probably pause this video and write this down on your notes if you have not already before we go on and try our example. Okay, so now let's try and factor this trinomial that we had looked at earlier, x squared plus 5x plus 6. Well, to do that, I need to know my A, B, and C values. A would be the 1, this somewhat invisible 1 that's always in front of anything, in front of the x squared in this case. B would be this positive 5 because it's the number in front of x. And C would be 6 because it's the number by itself. So if we build this X method, A times C would be 1 times 6, which is 6. Our B value of 5 would be written down here. And so it is exactly what I said before. We need to find two numbers that multiply to the top, aka 6, and add to the bottom, aka 5. Well, two numbers that would fit that description would be 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. And so our factors will simply be x plus 2 from the side and x plus 3, our other side number. That would be your answer. Let's take a look at another example. So with this one, you'll see we have an a value of 1 in front of the x squared. We have a b value of positive 2, and this time we have a negative c value, negative 63. So if we want to factor this, we'll again go to the x method. We're going to take a times c, so 1 times negative 63, which would be negative 63. We have a b value of 2. What you'll see here is that if you pay attention to your signs, you can kind of figure out some things about your two numbers you're going to find before you even have to start looking for factors. Meaning, for example, I noticed that I'm going to need to find two numbers that multiply to negative 63. There's only one way to get a negative number out of a multiplication problem, and that's having one number that is positive and one number that is negative. So when I'm looking for factors of 63, I'm not really looking for factors that add to 2. I'm looking for factors that have a difference of 2. So in this case, what that would be is 9 and negative 7. 9 times negative 7 is negative 63, and 9 minus 7 is 2. By the way, don't worry if you did not come up with the factors immediately that fast. That's not a big deal. Recognize that I'm just doing that for the speed of the video. It's okay if you have to take a minute or two and look around on your calculator or something like that, especially as we get to even bigger numbers. Since we found those side numbers, that means our factors will be x plus 9 and x minus 7. Let's take a look at one more example. Now what you may notice that is different about this one is that we have an a value that is different than 1. The process I have shown you so far for factoring will only work if you have an a value of 1, meaning you have just a 1, a positive 1 in front of the x squared. So if we have an a value that's different than 1, we have one of two options. Either a, like we're going to do here, we want to try and pull it out. We want to see if we can factor out a GCF. If we are unable to do that, we will have a different process we have to go through, which I'll show you on a different video. In this case, we notice that 2x squared, 6x, and negative 108 can all divide by 2. So we will simply GCF factor, sorry, wrong color, we will GCF factor that 2 out. Remember, we already did GCF factoring in an earlier notes video. That would leave us with x squared plus 3x minus 54. Now that we have factored this out, we've pulled that 2 out, now we can go to our x method using an a value of 1, a b value of 3, and a c value of negative 54. So a times c would be 1 times negative 54, which would be negative 54. B value of 3 means we are looking for two numbers that multiply to negative 54, but add to 3. If it has to multiply to negative 54, I know that means I have to have one positive and one negative number, because the only way you get a negative number from multiplication is if you have one positive and one negative. Which means really I'm looking for factors of 54 that have a difference of 3, as opposed to combining to 3. In this case, that would be 9 and 6. 9 times negative 6 is negative 54, and 9 minus 6 is positive 3. So the important thing here is that we still remember that we did pull this 2 out to begin with. We did GCF factor this 2 out. That needs to be part of our final answer. So we have 2, and then we also have x plus 9 and x minus 6 that we got from our x method. That would be your complete final answer for this.